Hi everyone, so we're back again for part 7 I believe of our videos on coding in Dogen. So whilst you were away I did a couple of commits. Let's have a quick look at what we've got. There's an easy way to jump over to the project from here. So from last night, which was around here, still struggling with our Windows CL. Many tests really. So we finished the day by trying to add a skeleton for the tagged values overrides transform. So since then we've implemented the variability overrides transform. We've created a set of types that are needed for this transform. Did a few simple commits, and we've plugged the transform into production, so that's into the production of the model. Finally, we added some overrides to the configuration option. So if we have a quick look, well, also the other thing that's consumed a large amount of time is to try to get Emacs to behave again. You can see here it took us the best part of an hour and 20 minutes to get smart parents to behave. So it's gone now. So you can finally return to our movement. So if I just have a quick look at the overrides transform. So if you look at this guy here, so we did a very simple implementation of the overrides transform. And what I'll do is but this is still being tested at present, so it's likely it's going to fail, but I'll run through it with you. And what I've done as well is I've plugged in the new options over here to the Dogen generation, so we can test this here. Last but not least, we have a log file somewhere around here. This particular one is for the assets model. Okay, so what we're going to do then is we're going to try to test this new feature. First we'll just generate version.assets.io. Now of course this will be very quick because we haven't enabled logging, so let's just try that again with logging this time. I'll take a little bit longer. Jump over to the log file. Now here, what we want to do is we want to look for our transform. So the expectation at present is probably to see very little from the transform. And what I'll do is just maximize the log file here. So as you can see here, the new transform is plugged in and is kicking in. It will be going through every single model. So it started by trying to run, interestingly enough we call it a configuration transform. This is our first bug, so this should really be tag values overrides transform. And exceeded our maximum white space, so let's break this line into two. I'll try to mumble a bit less. I noticed I'm mumbling quite a lot in the videos. So that was the first problem, but in fact, to make our life easier, let's just just highlight the lines matching this guy here, and yellow is fine presumably. Let's see if that works. Maybe I just did a little bit too much. This is a very large file, so highlight lines matching variables is not going to be very happy perhaps. We'll try highlight symbol instead. This tends to be a little bit more performant, but even that doesn't seem to be liking it. Well, we have to make do without any highlighting. This is a large multi-megabyte file, so Emacs sometimes gets a bit upset. So as you can see here, no variability horizon found, finish configuration transform in, and clearly the same thing is going to happen to a number of models here. Every single model of these, right? Which is what you expect. Okay, now so what we're going to try to do instead is we're going to try to well, first thing we're going to do is just add in an invalid variability override. Jump over to the logs. Or actually, let's first jump over to code generation. Right, so we've got the errors we'd expect, and we can see here that our transform attempted to parse the string and resulted in that. So let's do another test now. So if we say something like A 1 2 3 4 5. So in this particular case, we have all the fields. Let's see what the log file says. Right, this is interesting. So this is one of the things were worried about. So at present it's not possible to have empty values in our token. So this is a bit of a problem because we wanted the ability to say which is also quite an interesting thing. So we wanted the ability to say, okay, maybe I'm not supplying the element name or I'm not supplying the attribute name, so those are skipped, and the idea would be to provide you with blank values. But at the same time, one wonders if it would not be nicer to just deduce that by the position, and we always know that the last two are going to be the KVP, and we always know that first, second and third are going to be the elements and attribute, the model element and attribute names. So perhaps what we really want to do is we want to allow users to just apply between 3 to 5 elements of in the tuple, and then we determine from the 3 to 5 what to do. That might be more sensible because then we don't have to have lots of quotes, empty commas. So in that case we need to relax our check here. Start with, we'll say something like if token size is less than 3 or token size is greater than 5, then we have a problem. I'll fix my comments in a second. Let's just leave it like that for now. Now let's see what happens. What's the consequence of this then? So before we expected tokens to be 5, now we don't know. We expect a minimum of 3, so that's alright. So we know that the first one is always going to be the model name. It has to be present, and that's why we have 3. The model name must not be empty under any circumstance. Now, what we then need to do is we need to determine whether there is an element name or not. And the way we do this is we simply look at the numbers of tokens. So if we can say something like if tokens.size is greater than 3, then we would like to take, right, so probably let's just create a value here which is just the empty string. And what we'll do is we will so if we do something like this, if in fact we could probably do this just in the same expression here. So if the element name is greater than 3, no, its token size is greater than 3, then we would like to take the front, otherwise we'll just take the empty string. Now this very clever construction here, a slight problem of course is that we don't want to pop the front unless there's at least 3, right? So let's just go back to our original idea. So in this case we probably don't really need that empty. Right, so let's try this again. So if tokens.size is greater than 3, in other words if there's an element name, then we would like element name, which can no longer be consts. We like the element name to be equal to the tokens.front. We also like to pop tokens.front. Similarly, if the tokens.size is greater than 4, well, to be precise, equals to 5 really. In this particular case we want it to be basically anything above 3, so 4 and 5. So that's fine. So again, we would like the std string here to be blank by default, and then to be equal to the front. Okay. Then we're going to read the front. Not that it does matter actually. Right then. So now in theory should have the rest of the logic should be identical actually, because what we're now saying is let's fetch the element name. You can only do that if there's 3 tokens, more than 3 tokens. In other words, 4 or 5. And then we say, well, actually if there's 5, let's also fetch the attribute name. Then the rest of the logic takes into account empty names. So then really I should be able to do something like ABC. Of course now we need to compile our code generator first. If we try running it, right, I would expect that to error, but it hasn't, so let's have a look at what he thinks he's doing. Okay, so that's not too bad. So model is Dogen.assets, so we revise ABC, parsing string ABC, and then we have the ABC, and the variability rise is not applied to model, and it's presumably to every single model. Now, what I'd like to do is, if you supply some variability overrides, most interesting, it probably would also be nice to have variability overrides applied to every model, interestingly enough. Because one use case for this is that we will just supply the variability overrides for all Dogen models without regards for the name. So actually we just have to change the specification a little bit here. And also we have to remember to clock our work. We'll start this from 34. Now then, yeah, so before we assumed we always wanted to know the model name, but now that I think about it, actually be nice if there is no model name to just do it for any model. So let's relax that too. And then the idea is now that we can support up between 2 to 5. Right, so let's just relax this to 2 to 5. Less than 2 and then more than 5 is definitely going to be a problem. Now, observe how we now copy and paste a little bit. Here we can say if tokens.size, I mean you're going to obviously notice the pattern here, but what we're going to be doing is something like than before. So we come up with a model name, if the, well, presumably if it's 3 or greater, yes, correct. Then we just take the front, pop the front, Now we're going to say model name can be empty. So we will just basically say either yes, we can say something like if model name is empty, if not model name dot empty, and model name is equal to, now it's different from the model name. Well, in fact, we don't even have to worry about empty there. So if model name is not empty and model name is not equal to the model name that we're looking for, that's correct, therefore the override does not apply. So by the time we get here, there's only two cases. Either the model name is empty or the model name is not empty and it matches. Right, so that's exactly what we want. So let's just give that a try. Now I'm just gonna again try to run assets. Right, good. Type not found A. Now what is our condition at the moment? A, B, C. In fact, it should have been type not found B. So in this particular case we have 3 entries here. If the token dot size is greater than 3, that's not a good number, greater than 2 really. In other words 3 and 3 and more. That means we supply the model name, otherwise we haven't supplied the model name, so presumably this is why we're having this problem at present, hopefully. It seems to be trying to match the model name as if it was an element name, so seems a little bit healthier. Let's wait for the restart and let's look at our overrides. Okay, now let's see what it says. So, ABC, parsing string ABC, results ABC, that's good. Override is not applied to model. Model Dogen assets, variable to override model A. Very good, that's exactly what we want. Okay, now then, let's just do a quick test and say, well, actually, I want to override for all models at the model level with these parameters. Now what I expect to see in this particular case is, right, this is wrong. So we don't want type not found B, we would like it to say there's only 2, so therefore there are no types. Now, let's have a very careful look as to how we determine. So, element name starts as blank, tokens dot size clearly is not going to be greater than 3. Element is empty. So element name is empty, and that's where we would expect it to go. So what is happening here from the log file perspective? So we start with B and C, parsing CSV B and C, B and C. Ah. Oh, actually, believe it or not, it says worked a bit too well. We seem to be looking for a type called B. We seem to have populated a wrong container. So taggable, yes. So this is actually very good. It was so good that we caused a problem. So we should have populated the overrides container. Instead we populated the actual tagged values container, and this was working so well that we we broke because of course there is no value b, no field v in the features, so that then caused problems. Okay, so let's just run this again with a fix in. Right, okay, cool. So this is excellent. So what you're seeing here is now we're adding to the overrides the key value pair BC, and the overrides is finished here. Now, if we were to look at the end results of the transform chain, this time we'll use tracing to make our life slightly easier. So let's say we have tracing, detail. Let's just enable everything on tracing. Just rerun this again. Jump over to the log. Now what we'll do is we'll have a quick look at tracing. So if we just go down the chains, let's run engine. So we really want to follow this model chain here. And then sadly we need to figure out which one is our model. So what's the easiest way to do that? There's quite a few models here. Well, we could be lazy really and just look at the entire graph and just apply JQ dot to this guy here. This is a very large file. Oh, 1.6 meg. It's not actually that large. JQ seems to be struggling a little bit. So we'll just apply JQ to this chap here, and that contains every single model as it comes out of the injection pipeline. This is the whole model set. Otherwise we need to figure out which one is which here in this set of 15 models. Presumably the first one will be the target model actually, so perhaps it's not actually not that bad. So what happens if I just... no, of course Emacs with this usual async behavior is still trying to figure out what to do with that very large file. Perhaps the easiest thing to do is to try to kill. JQ is already finished, so it's just Emacs trying to format the output. See if we can convince Emacs to stop formatting. One of the annoying things about Emacs and its lack of proper async is every time you do something really silly, there's no easy way to then tell Emacs to stop doing it. Control G used to work, and it works for a lot of things, but not for everything, sadly. And you end up wasting a lot of time playing around with this sort of thing, which is not ideal when you haven't got a lot of time. So you probably see that Emacs is very busy at present. Let's do the usual kill USR1 7198. And then USR2. Still not sufficient to get Emacs back to us. Ah, here we are. Suddenly realized. So as I said, my theory is that this first model must be the target model. Let's have a quick look at this chap here. Not sure why we're connecting to client D to open up a JSON file. The Emacs is always a little bit out of whack after you've tried to cancel some long-running task. Not clear what's going on at present. I'd be very upset if I had to restart Emacs again, actually, because I've had to restart Emacs a few times the last few days. Very abnormal. Not really being very lucky at present. I think that that long delay caused all of our LSPs to restart, I think. This is really not ideal. It's also part of the work of developing with Emacs at present. It's whilst it's very good experience most of the time, few things, particularly when you do something silly like opening very large files and so on, it's really not quite nice experience still. Not very easy to know what's going on. Just enter these very tight loops. And sometimes you can get the debugger to help you. But not always. Yes, as you can see here, we've really not in a good state right now. Okay, right, let's not waste any more time, because time is of the essence. And I could give it another USR2 just to measure. And hopefully can recover Emacs. So what's happening at the moment is just that we've got very large files, or files that have got very long lines, which to be fair we use them quite often in Emacs, but it has to be said that Emacs does not like them as much as files with short lines. Okay, right, like I said before, sometimes you have to cut your losses, and it may appear that you are wasting time by restarting Emacs, but you'll spend even more time faffing around trying to get things going. Just be slightly more cautious this time. Okay, right, we have a proper blank Emacs here. So set background color to black, just to get away from the typical Doom theme. Right, so before anything else, let me just restart my music player. Can't do anything without my music. And we have Bongo library that we rely on. Okay, now then, just start creating our areas here. So if I just sub over to area 0, call this Bongo, jump over to area 1, and that's going to be our work. This is normally the sort of thing I do not that frequently, to be honest, but as it happens, I've been doing that a lot of late. The interesting thing is, how do you select? Seems like I'm a bad Emacs day today. Emacs modes. No, not supposed to do that. So Emacs. No, can't actually get Emacs going now. The other thing that's really peculiar, that's happened recently. I used to be able to go down when I was using Helm for the next batch of selections. Now, for whatever reason, after some updates, I can't do that anymore. I'm not entirely sure what is the key bindings to get us to the next bit. So I can't actually select Emacs from the second set of selections here. That is pretty curious. I wonder what's the quickest thing to do here. So Emacs. F1, no, you can't do F1. And we don't have our history, so well, we're gonna have to figure out how to use Helm properly. Let's have a quick look at it. Helm, Emacs, instructions. This is what tends to happen occasionally. You start doing one very simple thing, and then you end up getting sidetracked a lot. Okay, so So we have tab to list available actions, Control J to evoke the persistent action, whatever that means. Meta space to mark a candidate. Okay, CHM to help and return to the first action list. Now, presumably the problem we've got at present is that when we type Emacs, we'd like to move to the next section of Helm. Control XC is the default key binding for Helm prefix key. I wonder what that means. Control XC. No, undefined. Helm meta X and then type Helm to discover Helm commands. Filtered bookmarks, find files. This would have thought this would be a very simple thing to do. So we can autocomplete points by tab, blah blah blah, tab as a bar. I don't know what to do. Not entirely clear. What we need to do with Helm to move to the second. What if Alt? What's this? Emacs. So that allows us to move up and down in our history. As you can see, we can't. Wonder if I can say ending. There we are. Wow, that was hard work. Must be an easy way of doing this, to be honest, but there you are. So, good lord, this has been a very, very haphazard session. So let's just try to get to Dogen C++. So, a little bit frazzled, I'm afraid. So, yes. Oh yeah, so going back to what we're trying to do here, losing track of that point here. We've managed to get the integration with the new overrides, and we were trying to figure out if the population of the overrides check list errors. So we're trying to figure out whether the population of the overrides was happening correctly. And in order to do that, this is where we got a little bit lost, right? Sorry, this is a very, very rambly session, but we shall persevere. So we're just gonna make all my areas as I'm used to them. So normally I tend to have in area 3 my agile, and that's just basically the product backlog. Should we set these things to autofill? And then I tend to have my sprint open here. Sadly, because we have to kill Emacs, is probably not clocking correctly. So if I just keep all of this, and again set the autofill modes. Okay, right, cool. This point in time, what do we have? We have agile. Let's just get ourselves Git here as well. Can't really do any work without Git. Tend to have a master branch with Git work trees. I tend to have the master branch, and I tend to have integration, because most of the time we're just merging between these two branches, really. Let's just do an operation here. And also another operation there. Okay, cool. Oh, and of course, because you can't see my other monitor, we need, oh sorry, let me just finish this. Git on 4 into my shell. Not master, but an integration. So we'll just rename that buffer. Okay. And on 5, my area 4 compilation. Okay, so this is a very simple setup. Let's call this Dogen shell. I mean, I could actually just get Emacs to record these areas and remember some more things in the buffer. I just haven't had time to do that. That would be the sensible thing to do. Of course, I need another frame, which I'll leave here, outside of your view, sadly. Okay, cool. Try to get something resembling sensible setup. Let's go to compilation. Now, if I just go back again to my area 6, as we had a second ago, and this is my Dogen logs, this lovely Emacs restart. You can see why is that Emacs users struggle when Emacs restarts, because, you know, imagine if that session was running for, I don't know, several weeks. I'd have a lot of buffers open. It'd be very difficult to resume the state. So we were trying to regenerate. Alright, so this is where we were. So we reached the conclusion that in my injection pipeline, the first model is probably my the target model, and this is after all the processing. So you can see here, it might be a good time to actually explain how this the tracing model works. So you see, for each transform, we do a dump of the model. If the transform supports it before and after, we'd have an input and an output. If it just supports inputs, then we just have the input. Now, there's the bug. So clearly the tagged override should have an input and an output. And also we want to know if this refers to the right model. So I'll just do a JQ dot here. Now, if you remember a second ago, JQ didn't work very well. That's because it was a very large model. If I just do a smaller model, JQ should be a little bit more responsive. It's still quite large, but small in comparison to what we were trying to do before, which I think was in the region of 16 meg. This is only 1 point something, 2.7 meg. Hopefully JSON mode's not gonna go crazy on us. It'll just take a little while, but we'll get there. Now this will tell us what model we have. Sadly this is actually the dia model, but we should be able to figure out its name. It is taking a while, but it got there in the end. So if I just look for metadata in this model, as you can see everything is a little bit slower, but still 1.6 or 2.7 meg, 3 meg really is not that much for Emacs really. I'm surprised it's actually that slow at the moment. I'm wondering if there's something not quite right. My Emacs has been misbehaving a bit of late. Right, there we are. So this is Dogen.assets as expected. Okay, so we got the right model. Now, first let's just fix the bug that we do not have. We do have an end transform. Right, the problem with this then must be that we're doing some early return somewhere. So let's have a quick look at the early returns. So if there are no viability overrides that we return, that's fine, because we don't really care about the end state, we didn't change anything. If there are viability overrides, there shouldn't really be any other returns here. And there aren't. So that's just an end transform, and that dumps the model. Okay, so that's actually a little bit puzzling, because it seems like we've done everything as we should. So I would have thought we should really have both the input and the output. We do. It's just... Yes, okay, cool. So as you can see, what's happening here is that there's a bug in the way we're setting up the transforms. So this should have been 0, 1, 2, 3, 4, 5, 6. So there's some kind of slight bug in how the tracer is adding the models. So we'll just take a note. I mean, this is obviously not ideal, but let's not get too distracted. So tracer numbering of dumped models is incorrect. We seem to be skipping numbers when dumping trace models. And what we can do is we can literally just take our output from here and literally just dump it here. And we don't necessarily need every single bit of it, so let's just perhaps look for 0 might not be a very good thing to look for. What is the best? Well, actually, this is actually pretty constant, so we'll just do this is special character here, and then go to the next line, see what that does, and that should solve our problem. Yeah, Emacs is definitely behaving rather erratically at the moment. This is not normal. You can see it's locking up again. Not entirely sure what's going on with my Emacs. I mean, like I said previously, even a 16 meg file, I mean, this is just acting very weirdly. I wonder if our latest updates, I'm on Debian testing, so it's possible that you update when you shouldn't really. I mean, most of the time, and I mean the vast majority of the times, no problem, but occasionally you get these situations where you don't really know, things just start behaving a bit strangely. For Emacs to have to be restarted several times in a week is rather uncommon. So there's something really strange going on at present. Anyway, we captured our story here. We will look into how to solve that problem at some point in the future. What we really care about is we've done everything right. Our transform is here. We can JQ it again. We're probably going to have to wait a little while. Actually, a bit better this time. Let's fire off JSON modes. So we're outputting the tagged values. Yeah, and see, this is very, very strange. Don't seem to be able to do anything without Emacs locking up. But on the plus side, we got what we wanted. So we have an injection model. We can see the tagged values. These are the actual tagged values as normal. So now, just so we understand what we mean by this is the metadata that's being applied to the model. In this particular case, all of these keys here are being stored in tagged values in the beginning of the pipeline. So it should be in the right order as you see here, and these are all these things, injection.com and so forth, all the way to the default profile. Now, if I then look at the overrides, quite nicely, the overrides are here, model level. That's exactly what you'd expect. Okay, so that's very good. Now, we know what the model name is, Dogen.assets. So what we'll do now is, for good measure, we'll try the second incantation, which is, let's try to override it using a model name, the correct model name this time. Still have to bear with Emacs. So if I just do generate dogen.assets.io, so this is the first tests. We expect the model to say no can do. Model name is different. Let's see what the log file says. And where is our transform? Just here. We'll just maximize this bit. In fact, we'll just put the JSON at the bottom, I think. Shell command output. Should have had a shell command output that we do. There it is. So yeah, so you can see Dogen assets there. And interesting, very interesting here. So let's just follow through what the transform is doing. So the transform starts here. It starts to build some metrics, because of course we called the tracer at the beginning of the transform. That's expect. We obtain the variability overrides, split it and does this thing. Eventually interestingly enough, we don't seem to be doing any checking. Seems like we're missing some entries here in the log file, doesn't it? We'd expect to see some entry after variability overrides. So we parse the CSV string, we obtain the results, and then suddenly we just have this massive jump to the finish tag values override. So I don't think we found another problem here. Let's have a look at what the code thinks is doing. So we are entering it here, dumping the overrides as we'd expect. And then check whether we already inserted, we did splitting, we know everything's fine up to the splitting. And this is an interesting thing. So if the model name is not empty, or this is an AND or it's an AND as you expect. My maths is not as good as it used to be. So if the model name is not empty and the model name is different from the actual model name is different from the model name from the override, we expect to trace that the override is not applied to the model. So this is what I wanted to see. Instead, we seem to have gone somewhere else, so what I'll do is just for good measure, just gonna type here these two things, just so we can see what this thing thinks is doing. Give it slightly more sensible names such as override. Model name. Right. And sorry, let me just make sure I can see the compilation buffer in my other monitor. All these Emacs restarts. And of course we want to build Dogen, and then we want to generate again the model. Right, so of course we need to make sure the model name is correct, which it is now. And we go back to our log. Right, let's just double check we're not doing anything silly here. Assets model. This is the log assets model. It was refreshed, hopefully. And then here's our transform. Yeah, as you can see, this is kind of what you'd expect. There's a very good match there between the model name and the override model name. So we're doing well. That's why we're not entering this. So then, I see, I think already what the problem is. So if the element name is empty, we apply the override to the model itself and we continue. So the problem we have here is that and this is one of the things about logging really, we didn't really do our job when it came to logging. We should have said something like applying override to model. We should also probably say something like the very top, processing overrides, and then the overrides. See, without these kind of clues, it becomes extremely difficult to understand what it is that we're doing. So what we really want to do is to make sure you can clearly see sort of the trace of what's happening. So we're processing the overrides, and then we are applying the override to model. So maybe we should just say applied, because we've already applied it. And then in these other cases, whenever there's a match, we should say something such as overrides matches elements, name, and similarly if it matches the attributes, should also note that we can match the attribute. So this is very good, because it will help us to know what's going on. So when you look at the log file, we have some idea what's going on. And here we probably want to know the element name. It is quite boring curating log files, but it's a very important activity of the programmer, because if your log file doesn't tell you exactly what happened when you need it, when you're in production trying to look for something, you will spend hours on end debugging, when in reality it should be in a 5-second job if your log file was doing its job properly. So now we should look at a complete story of what's going on here. See, now you can see clearly here the model name, the override model name, and it's applied. So really what we want to do here is more like, we want to see the override that we're processing, we want to see the current model. Yes, we can see that here, and probably should just see the override model name. Really, we don't need to see both. So this is the other thing as well. It's important when you're creating the log file, is you just output really what needs to be shown, not everything, because otherwise of course the log files will become massive and useless. So what you really want to do is to make sure that you output just what you need to output in the log file. Not too much, but not too little. Sort of the Goldilocks of log files. Right, so there we are. This will tell us what the override model name is, and we should do something similar for all of these. And as you can imagine, these will become quite useful when something goes wrong. Of course, you know, I'm not doing test-driven development at the moment. I should probably. We're just doing manual testing. Really, we should have tests that are executing these scenarios, and we probably will do these in a minute, but I'm just being a bit lazy at the moment. It's more like a log-driven development, really. So let's have a look at what the log file is telling us. So the override model name is there. Apply the override to model. Now of course you're going to notice that we didn't do our job when it came to ensuring, no, that's correct. I just want to make sure we had quotes around the strings so that when the string is empty, we know for sure what's going on. So attribute is not an element, it's an attribute. So no, it is empty, so sorry. Override matches element, otherwise empty. So that is correct, should have been element. And here should be attributes with a name. And there we are. Okay, cool. So now then, let's try our second test, which is to say, can I match an element? So for that, first let's see if we can find an element that lives. Well, we don't really have any elements that live in the global space, so let's just jump over to a different model. Let's go to Dogen.dia. This tests. So we'll just run this chap again, go up to logs, and locate Dogen.dia and open up its log. Now, at present, we probably will see override model is this, override does not back to model. Bang, 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 and we're very happy. Okay, that sounds very good. Now then, what we're going to do is jump over to our tests and say Dogen. And then, well, first we'll just start by saying Dogen, and let's just see that the log file is indeed saying something sensible. We'll do that. Apply the override to model, that's good. Now we will try something slightly more complicated. What happens if I attempt to apply the override to, say, a type? So something like this. Now we have to be very careful. Right, so you can see the overrides being transported correctly, being split correctly. Bang, here we are, side problem. So override model name is Dogen, but then it doesn't bother to look and see this is an element level override. So what we expect to see here, which we're not seeing, is we started off with the model name, which is here. If the model name does not match, you're not going to have the override. That's good. Empty model names match any model. Right, so yeah, so if the token size greater than 3, 1, 2, 3, 4, override element name. So we'd expect to see something happening in the element name space. So it's rather interesting that we don't even bother with the element name, isn't it? And clearly element name is not empty, or should not be empty. So I think there's something not quite right with this processing of model name. Do you know what it is? It's just silliness, really. So what we need to do is we need to be very careful to remember how many tokens we started off with, because we keep popping things. So let's just do something like const auto number of tokens, or even token size even. Right, let's just do something like this to remember what the token size was when we started, and then what we'll do is just replace all these calls to token size, because of course what's happening is once you start fiddling with a collection by popping things, token size will have a different size. I mean, this is obvious, but clearly it wasn't when we were writing this code. And it's because the size is different, all of this clever logic will not work. So let's just rebuild Dogen if we can. Of course, it's important to make sure the collection really exists before we try to get the size of it. One would have thought. Right, so now then, hopefully we'll see something a little bit more sensible. Well, what's interesting. So we do have an override model element name, we do have an override element name, but now we're applying overrides to area of the elements. So why would that be? If the element name is empty, well, it's not the case. So for each element, if the element's name is equal, of course, one thing we probably want to do is to say found is equal to true. And then we do the processing for the attributes. We already do found equals to true. But one thing we have to be careful here is we don't want to say find equals to true unless... Yeah, so we have to be careful with this. This is actually quite a complex logic. I didn't realize it was going to be this complicated, but it is quite complex. Because you have to remember, we're trying to say that we have to locate the elements, but if there is an attribute name, then that element is not what we're matching on, is the attribute, in which case we say found true. Only then can you know. However, if the attribute name is empty, then we found it already. So perhaps what we want to do is something like if they are equal and so if we already have if attribute name is empty at the bottom, so clearly that should have been sufficient, isn't it? Because we will come through here. If we have no attribute name, the override match the element itself. But crucially, else continue. Imagine it's important not to match if element name is different. So it's actually just a schoolboy error more likely than not. Okay, so now it's saying that we did not find type B. So let's have a quick look at the log file. Okay, that looks good. Let's have a look at the error. Once more, this is going to be a very simple and silly error. We keep on updating tagged values, and we really should be doing that override tagged values. Okay, this is just confusing. Do a quick search for tagged values. Right, so yet again we want to override tagged values. And the way There you go. Okay, so once more, we'll just build and regenerate. Right, okay, right, so then let's just return to our log file. Now we didn't get any errors, which is a good thing. Right, there's our transform. And it looks like it applied to the element name, right? So what we're going to do then is we're going to try to use some slightly more unique, shall we say, keys and values. If I do something like gen, what I actually meant to do is more like so I could just just go back to this buffer then and let's obtain the result of this UIDGen, and let's just make that our value. This will make it really easy to find what we're looking for. And then let's run again this chap. Now if I go up to 6, right, so now we know for sure in the tracing, although we know there's a bug in tracing, but let's ignore that for now. If I go to the engine processing, I know for sure the first thing I get is tracing, and I know my output is this chap here. So again, I'm just going to JQ dot. You know, it's going to take a while. Let's be quicker this time. Maybe Max does behave. Right. So now what we want to do is we're going to see what is going on for this element. So it doesn't have any tag values. No, but that's about right. And we know this name is multiprocessor configuration. We also know there's no one else with this key. So this seems like we're finding the right place. This is a good thing. So now we will try not to target the type itself, but the attribute in the type. Of course you are going to say, well, why are you going through all of this since we only need to update the model? We didn't really need to go through all this pain. Which is a good point, but first we'll give it a go at trying to do this, and if it's too hard we might revert to a simple implementation. For now, there's still some hope that this is not that hard. So let's have a quick look at the error. The attribute matches multiple elements, okay. So override element name, override attribute. I actually think this is going to be an absolutely trivial bug. We forgot to set founds to true. No, we did. There it is. But of course this is a bit silly, isn't it? So we probably should place all of this in here. So what we're saying is for each attribute inside of the elements, if the attribute name matches, and if we've already seen it before, well, it's a bit weird because you should match more than once. Otherwise, found is equal to true, get tag values, slot it in, away you go. Continue, because they may be interesting. Yeah, continue, so we'll get to the next attributes. Now, of course, he probably will say, slight easy way of writing that code, and you probably are right. We could just basically say continue if it's different. Otherwise it's because obviously it's the same. So we can clearly clean this up a little bit, but first let's just get this to work. I always like to do things in 2 or 3 passes. First do worst looking algorithm ever, but that actually does what you want it to do. And after that, check that in, of course, and then after that, try to clean it up until it looks nice without breaking. So override element name, override attribute name, override matches elements, override matches attributes, apply the override to dry elements. Okay, cool. So that looks very good. Now, for some random reason, tracing has disappeared. Let's have a quick look at how. Oh, I forgot to refresh our diode. Hopefully our yes, our grid is still here. Now let's just make sure that we see this in the attribute, and the attribute is named as expected. Right, cool. So there's only one. Okay, that's very good. So this basically means that we're now able to target models, elements, and attributes quite precisely, and these are obviously we tested for the case where this is all happening outside of a namespace. Now I'd like to see the exact same thing, but for a namespace. So for example, let's say transforms context. Of course we'll write some tests for all this stuff, but for now, so we tested model processing configuration, so now we want to say transforms context. I'm not entirely sure if the syntax for scoping is the C++ syntax, but let's try it, see what happens. So, dia. Righty, so let's have a quick look at what these things is happening here. So the model name is Dogen. No, of course this is where it helps to be looking at the right log file. But now the model name is Dogen.assets is correct. The override element is concept. It matches element transforms our concept, and now apply the element to that. Okay, that looks good. For good measure, we'll just have a quick look at value overrides. But don't have to do this, but as you can imagine, assets model is much larger than the previous model, so it takes a little bit longer. Right, so you can see the override here. You can see some tagged values here as well. It's probably been coming from the profile, so that's fine. And the name is context. So we're quite nicely picking up something inside of a namespace, so that's good. And just because I'm slightly paranoid, let's just get an attribute as well. And with that, I'm going to deem this quick testing complete. It's obviously not exhaustive, and we should really have tests, but okay, we get an error. Let's just show you what I see. So the error is saying they could not apply these overrides, which is interesting, because this all looks alright to me. So I think this is where there's probably some kind of a bug. So what we probably want to do, this is a bit annoying, we'll just have to some output here, but I mean we don't really want to output every single attribute, otherwise you can imagine we're going to end up with lots of attributes. But I'd like to just see what the attribute name, just make a temporary log for this. What is the difference in attribute names? I think clearly we have some difference because we're not matching an attribute name, or of course we may have done some typo somewhere, but just to be on the safe side, let's have a look. Ah, that looks pretty identical. Rather. That's rather surprising. Let's have a look. This almost seems like the exact identical case of where I said a second ago. Not entirely sure why we're not matching. So the attribute name looks good. So we match the element, clearly. You know that the attribute name is not empty. Let's just look a little more carefully at the log file. It seems like we've broken something. So everything looks good up to matching the elements. So if the attribute name is empty, now we know it's not because we just did a dump of that. So we're going to go through each attribute. What we did not do is we did not dump the actual attribute names. We dumped the override attribute name. So let's try this again. Right, we want to see what Dogen has decided to name these attributes. It will be interesting. Presumably some kind of bug. That's what's happening here, is that we're probably adding something silly like the namespace to the attribute name. Oh, no, we're not. Okay. What are these attribute names then? Feature model. That's actually quite good. So we thought we were in the injection model, we're actually in the assets model. And so if I just go back and look at the model that I just generated, it's the assets model, clearly. So okay, this makes perfect sense. This is actually not a bug, but a feature. Correctly detected we're in the wrong model. So this is why we want to throw in this situation, so we know we're in the wrong model. Right, as you can see, we're in the wrong model there. So I'm just gonna change that to, I don't know, tracer sounds good to me. Let's change that to tracer. Don't need this anymore. Change it to tracer, regenerate the assets model. Everything seems happier now. Oh. And apply the override to the element tracer, that's very good. Quick check at what we think is the context. We are in assets, hopefully. We are. Let's let JQ do his magic. Okay, now let's look for our beloved GUID. And it's here. Let's double check that it is in the right place. So what do we see? We see the overrides. Okay, that are good. They have a name, and the name is tracer. There's only one entry for this GUID. Okay, brilliant. So now we prove that this works with namespaces as well, and seems to be overriding what we want. Okay, so this is actually quite good. So just to summarize what's been a pretty eventful evening, probably have to call it a day soon. In fact, it's already time. So, well, it's been a lot of stuff happened here, and we didn't really do a lot. If you look in terms of the commits we're doing today, it's mainly a testing sort of thing. But what we figured out was that the logic that we started off with wasn't particularly good logic, and it involved creating lots and lots of CSVs with empty quotes and commas and so on, which wouldn't look very nice and be very pleasant to use. So we decided to instead to allow a variable number of fields and to then determine how to process those fields. We fixed up all sorts of bugs in the logic of how these fields were being used, tidied everything up around that, and then once we'd done that, then we went to testing all the permutations. Now we seem to be happy enough that the overrides are being propagated correctly. What we'll do with this is we will ignore all these changes. I'll leave this as a stash because I need them for tomorrow. And in general, we're happy enough that the overrides are getting into the injection model and they're being put in where we'd expect to see them. So what we now need to do once that's done is we need to make use of these overrides, which is what we'll look into tomorrow. So for today, we'll just close this story, which is mainly a set of testing work, really. See, we're closely getting closer and closer to the 80 hours, which is the end of the sprint. So we might actually finish the sprint this weekend. I will probably allow a few hours more, but so sorry if I just go up to Git and right, we have some changes here in the injection model. I think these are not good changes. I think this is just because I forgot to close and open the model again after I've obtained the model from my laptop. So what we'll do is, just to be on the safe side, we'll just close all of these guys and we'll reopen them. So if we just say injection fixes to the tagged values overrides logic. If we say allow a variable number of fields in CSV string instead of forcing of requiring perhaps empty fields, fixes to model elements and attribute processing logic, improvements to logging. And that's about it, really, something like that. Okay, so we have one meager commit for all these hours of work, but sometimes it's like that. And then we'll push this across to our build servers and CI. Build is still not ideal at present. Not quite sorted all of our issues, but we're not too far off now. I think the main problem really is the timeouts on GCC and the timeouts on Windows as well. Oh, funnily enough, just as I say that, we managed to get a completely green build in Windows, but that was more luck than anything else. We've been getting a lot of red ones. Okay, I think this is probably going to be all for today. Shall continue with a longer session tomorrow. Thanks for watching.